Hello everyone, this is Chadni Islam from CRES Research Group of University of Adelaide. Here I am going to present our work on architecture-centric support for integrating security tools in a security orchestration platform. This work has been carried out as part of my PhD research under the supervision of Professor Muhammad Ali Babar and Dr. Surya Nepal. I will first provide an overview of security orchestration, then what are the challenges that we are trying to overcome through this work, followed by our research goal and proposed solution. Next, I will show how we have evaluated the work, and finally, I will conclude my presentation by highlighting the limitation and future work. The Security Operations Center of an organization uses a variety of security tools to protect an organization information and technology infrastructure. One of the key challenges of Security Operations Center is to quickly integrate these security tools to perform their operational activities because these security tools are not interoperable and they work in silos. To address this challenge, increasing adoption of security orchestration platform has been seen in the Security Operations Center environment. A security orchestration platform enables integration, orchestration, and automation of the activities performed by the security tools and human expert. Deployment of a security orchestration platform requires an organization to assess the existing security tool capability and prepare incident response plan. By security tool capability, we mean the ability of a security tool to perform an activity. For example, block an IP or isolate an endpoint. However, the emerging threat behavior causes changes in the deployment and execution environment of a security orchestration platform by changing the security tools or the incident response plan. However, the changes in the orchestration platform are not straightforward because existing security orchestration platform lack proper abstraction for designing such a platform at the architecture level. Most of the existing platforms are implemented in ad hoc manner without much attention to the underlying infrastructure. Therefore, it becomes difficult to embed agility in such a platform. Also, ad hoc changes make the architecture complex that make it hard to evolve. We also observe there is a lack of conceptual and practical guidelines for optimal architecture design decision. Here's come our research how software architecture can play a role in improving the design practices of a security orchestration platform. We found that an architecture-centric approach is expected to help in reducing the design complexity of a security orchestration platform by modularizing the functional and non-functional requirements. We first propose a concept map of a security orchestration platform that defines and relates the key concept of such platform's design space. The concept map shows that an organization generally deploy a security orchestration platform on top of existing security tools and infrastructure. A developer of a security orchestration platform design and develop different integration mechanisms such as API or plugins to integrate these security tools. Besides this, a security orchestration platform also runs and manages orchestration process that are generally designed in the form of a set of playbook. Next, we provide a layered architecture that modularizes the key components into 6 different layers to ensure the functional and non-functional requirement of a security orchestration platform. We consider 2 functional requirements, one where a security orchestration platform work as a unifier or hub, and another the security orchestration platform work as a coordinator. We consider 3 quality attributes: integrability, interpretability, and interoperability. We design the architecture in 2 levels of abstraction. The layers provide the first level of abstraction and the components in each layer provide the lower level of abstraction. From the design space of a security orchestration platform, we found that integrated security tools and orchestration platform mainly govern the task of a security orchestration platform. Thus, we consider the architecture design decision from process and technology perspective for automatically integrating security tool and interpreting activities. For example, we consider the integration process and interpretation process, such as how an orchestration platform integrates security tool and how it can interpret the data generated by different security tools. To evaluate the proposed approaches, we have developed a proof of concept system leveraging the proposed architecture approach. We evaluate the result based on two scenarios and we consider two types of changes, one change in the security tool and change in the incident response plan. We consider several types of security tools with varied capability and selected 24 different capabilities of these tools. Here we show some example security tool capabilities and activities and also the incident response plan. We have selected 21 incident response plan to fit the capabilities of the security tool. This is our implementation architecture. We consider semantic-based integration for integrating security tool. The data from the security tool are accessible through APIs or wrapper. To enable semantic interpretability, we design an ontology to formalize security tools, their capabilities, and activities of the incident response plan. We further design an SPARQL query engine and interpreter to retrieve the data from the ontology and interpret the data for further processing. Besides this, we have designed and implemented a script to define the automated integration process, which includes selecting the security tool based on activity description, interpreting their capabilities, and formulating the input commands to invoke a security tool by calling appropriate API. The orchestrator mainly coordinates all the communication. An example of selected set of properties of security tool class of an ontology is shown here. Here we show an example of data transfer from Splunk to Lima Charlie using the automated interpretation process, which is part of the integration process. Here the output of Splunk is sent to Lima Charlie via the orchestrator, where the orchestrator collects the output, interpreted it, and formulate the input for Lima Charlie. For automating the integration of new tools, we consider malware information sharing platform or MIPS as a new tool and different type of integration approaches. With static and wrapper-based integration approach, integrating a single tool would require development of at least one component and connection of the component with the orchestrator. With semantic-based integration approach, we only need to update security tool details in the ontology. The connection between the ontology and other components have already been designed and that do not require any changes. Thus, with semantic-based integration approach, number of component and connection remains constant with integration of new security tools. For automating the interpretation of the activities to execute an incident response plan, we consider 48 new plans and 2 different implementation of the security orchestration platform. With non-modular and monolithic implementation, each playbook is designed for a specific set of incident response plan, which cannot be reused even if the new plan is a subset of the existing one. Thus, a user would require to modify the existing playbook to execute the new plan. Developing a playbook would require an understanding of the playbook structures and knowledge of the available security tool, also developing scripts to access the generated data and so on. With our implementation architecture, that is modularized architecture, the process for automatically identifying the capabilities required to execute an activity or selecting the security tools are already defined. So a user would not require to manually identify the tools or update the playbook. Thus, considering the architecture design decision from the beginning of the design and development of our orchestration platform make it easier and require less overhead compared to the other approaches to execute the new plan. Some limitation of our work is that the developed system is based on freely available tools and their capabilities, and we only consider few quality attributes and 2 scenarios. However, our work has laid foundation for future research on the design space and deployment automation of security orchestration platform. In future, we plan to conduct large-scale mapping study of the existing security orchestration platform and incident response plan onto architecture design decisions to generate pattern and hide interaction among different components across multiple technologies. Our work shows that exploring and understanding the architecture design decisions Before designing and implementing a security orchestration platform is a valuable task. Capturing the architecture design decisions would help both developer as well as security operations center staff of an organization to systemize their decision. We have observed that considering the principal dimension improves the security orchestration platform's design practices. These are some of the references that can be followed with this work. I would like to conclude my presentation by acknowledging the contribution of CREST team members for their feedback in improving this work. Thank you for listening. Questions and suggestions are highly appreciated.